Hello, gentlemen. I wanted to talk to you a little bit about how you would do this graph, how you'd find the slope of a point on this graph. So I'm going to do it at 1 second. I didn't ask you to do it at 1 second, so therefore I'm not doing your work now. So we're try to find the slope right over here. I'm going to draw a tangent line. Ta-da! I just used the edge of a calculator to do it, actually. Now, you'll notice that it doesn't cross the graph. You might ask, well, what if we, and Liam actually brought this up in class, if I move this graph a little bit, if I tilted it a little bit, it would still be a pretty good tangent line. And all I can say is, yeah, there's going to be a little bit of error in your doing these, but try your best. So now I'll pick 2 points. Let's find this beginning point over here, let's say, and this point over here. Okay, this point is 2.2 seconds and 0.3, let's see, this is 0.2, that's 0.3, that's 0.35, that's like 0.375 meters, all right? And this one over here is, let's see, the time is 0.4 seconds and the position is this is again 0.2 meters, this is 0.3 meters, so this is 0.25, so it's like 0.24, right? Okay, so then the slope, m, is equal to y2 minus y1 over x2 minus x1. Well, y2 and y1 are these, 0.375, 0.24, so I'll subtract those, and I'll get 0.135 meters. The x2 minus x1 is going to be 2.2 minus 0.4 seconds. That's going to be 1.8 seconds. And the slope, if I calculate that out using the other side of my calculator, I get 0.075 meters divided by seconds, right? So again, you're going to do that same sort of thing here, showing me your points 1 and point 2 in the kind of XY form. So like if I were going to write that in this form, let's say I was doing 1 second, point 1 would have been 0.4 seconds and 0.024 meters, right? It extends a little bit out. Point 2, I just put 2.2 seconds here, 0.375 meters. Okay, and there you go. You just fill that out. You find your delta t. It's just subtracting the times and then subtracting, and then you find delta d. That's subtracting the two d's, right? Just what I did over here: y2 minus y1, x2 minus x1, and then you divide to find the slope. Okay, so it asks you to answer as step 2c. Make sure you do that, and then do d and e in your log, and we'll talk about those. And on the next page, like I said in class, it's much more straightforward because this velocity time graph. It's a line, right? So hopefully you're going to find the same slope at every single point. Now you might ask, how do I draw a tangent line for a line? Well, it's easy, right? Let's say you're trying to find the slope at here. I just draw a tangent line. Zoop. The tangent line for a straight line is the line itself, right? It doesn't. You can't draw something that crosses the line. It has to be the line itself. So it's just going to be draw a line on a line. You can even skip the part where you actually physically draw the line, right? And just start taking points, a point over here, maybe and a point over here. You'll draw those down and you'll find your slope. And hopefully, again, you'll find the slope is the same at each point. Okay? And then you'll answer these things that it asks you to do. All right, gentlemen, enjoy your days. I'll see you tomorrow. Remember, this is hard. Come in after school with questions if you want, but don't come in with nothing. Take care.